Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Jagwani. I am from Department of Computer Science, Arbet College, University of Delhi. So in this series of lectures which we are going through, named as Introduction to Programming in C++, today's topic is function overloading, and in order to tell you about this topic in detail, let me explain it here that we are going to take this topic in kind of two parts. Today we will be taking the first part and the second part in the upcoming lecture. So the topic, as I have told you, is function overloading. So function overloading, basically it is a term which comes under the topic of polymorphism. Now if you can recall, when we have started this series and we have gone through the object oriented programming paradigm, I have told you that one of the pillars of object oriented programming paradigm is polymorphism. So function overloading is actually a way to achieve polymorphism in C++. Now let us try to understand first that what is polymorphism, and then we will see how it is achieved with the help of function overloading or some other procedures if available. So now coming to polymorphism. Polymorphism is actually a term which is a combination of two different terms. One is poly, another one is morph. So poly means many, morph is a form. So basically, if I am if I try to connect this definition with a mechanism of C++, I will say ability of a message or a function, you can say, to be displayed in more than one form is known as polymorphism. So basically, either it is a message or it is a function, and it is being taken or it is being displayed in kind of more, not only in a single form but more than one form. So that is going to be called as polymorphism. So polymorphism, if we can see under the lens of C++ specifically, we have two types of polymorphism. One is compile time polymorphism and another one is runtime polymorphism. I will be exploring these two categories of polymorphism in detail, but as the name suggests here, compile time polymorphism is something which is achievable at the time of compilation. Similarly, runtime shows that it is we can say implemented or it is achievable at the time of running the program. Dividing this compile time polymorphism further, this compile time polymorphism can be achieved either with the help of function overloading or operator overloading. So if a function or a message is having many forms, we call it as function overloading, and if it is done for an operator, that means the operator is having more than one form, so it is operator overloading. So we will be drilling down into more details of these terms. And what about runtime polymorphism? So runtime polymorphism is here we can say achieved with the help of virtual functions as well as with the help of pointers, because virtual functions will take some pointers essentially with them. So this was we can say the differentiation of different forms of polymorphism in C++. Now let us try to take those two forms into detail. So first let's say compile time polymorphism. So compile time polymorphism, as I have told you, it is about either the functions or the operators. So presently we will be more involved into functions, and operators we will be taking at a later stage. So the overloaded functions through which we are going to achieve compile time polymorphism are, we can say, some functions which are having same name but different arguments. So the name is same but the type and number of arguments is different. So basically your overloaded functions or polymorphized functions, I can say, are invoked by matching the type and number of the arguments. I'll explain it further with the help of an example. So basically this information is available to the system at the compile time therefore compiler is going to select the appropriate function at the compile time, and hence it is known as compile time polymorphism. So now let us try to see kind of elaborate with with the help of an example. For example, I am having a function sum which is having two arguments a and b, and another function same named as sum which is same, taking three arguments a, b and c. So one which is taking two arguments will be returning a plus b, and one which is taking three arguments which will be returning a plus b plus c. So what is different here? The difference here is just the number of we can say arguments. So we can say these two functions, sum with two variables and sum with two parameters, sorry. So sum with two parameters and sum with three parameters is basically, these are known as overloaded functions. So this information is available at the compile time, and hence compiler is going to select the appropriate function. So how? So in the main, if I am going to call sum 10,5, it is very obvious that kind of version which is having two arguments will be called. Or if it is if in the main function I am writing sum 10,5,5, then it is very kind of very much clear that compiler is going to call a function which is having three arguments. So this kind of thing is known as function overloading. We will be seeing programs related to it in a short while, and the operator overloading is also included in this compile time polymorphism. It is not only function overloading, operator overloading is also included, and this compile time polymorphism is actually also known by two other terms which are known as static binding and early binding. So compile time polymorphism is also called static binding, it is also called early binding as well. Coming to the kind of details of runtime polymorphism, if we can see. So runtime polymorphism is achieved when the object's method is invoked at the runtime instead of compile time. So the method which is being called by an object within the main function is not being invoked at the time of compilation, rather it is being invoked at the time of running the program. So that's why it is known as runtime polymorphism, and it is achieved by as I have told you in the initial figure, it is achieved by method overriding, which is also known as dynamic binding or late binding. So runtime polymorphism is having kind of two other names which are dynamic binding, or we can also say late binding. Now in order to understand the difference, more of the difference between this compile time and polymorphism, compile time polymorphism and runtime polymorphism, let us see. So in compile time polymorphism, what actually is happening? The function is invoked, the correct function according to the call is going to be invoked at the time of compilation, while in runtime polymorphism the function to be invoked is known at the time of running the program, or we can say at the runtime. Now, as I have told you, compile time polymorphism also known as kind of early binding, static binding, while runtime polymorphism is also better known as dynamic binding and late binding. So what actually happening in compile time polymorphism, more than one method are having the same name but different number of parameters or different type of parameters. It is not only the number, it could be the type of parameters which could be different. In overriding or in runtime polymorphism, more than one method is having the same number, same name, same number of parameters and the type of parameters. So all things are same depending upon how it is being called with the help of pointers, we can say. There it creates a difference. So basically overriding, we can say it is a runtime polymorphism where more than one method are having same name, same number of parameters and same type of parameters, while in overloading, the overloading compile time polymorphism, the name of the method is same, but the number or and type of the parameter is different. In overriding, which is runtime polymorphism, name is same, number of parameters and the type of parameters is also same. So how this kind of this runtime polymorphism is achieved, we will see it kind of in our upcoming lectures as well. Now compile time polymorphism, I told you it is function overloading or operator overloading. Runtime polymorphism is achieved with the help of virtual functions and pointers. Now coming to the issue of speed. So compile time polymorphism provides you fast execution because it is kind of well known at the compile time, and it fastens the process. But as far as runtime polymorphism is concerned, it provides slow execution as it is known at the runtime only. So before runtime, the correct version of the method or kind of we can say function or the message to be called is not known. So that time kind of that is not known till the runtime. So it is a bit slower. Coming to the flexibility details, obviously, now this is very kind of we can say logical to say that compile time polymorphism is less flexible, as we can say all the things execute or get their binding at the compile time. But runtime polymorphism or overriding is considered as a more flexible way out, as the things execute at the runtime. So this is what actually till this point what we did till this point. If I kind of want to recapitulate, so what we did is we have seen what actually this polymorphism is, what is kind of its we can say in this object oriented programming paradigm. Then we have seen the types of polymorphism in C++, which is overloading and overriding, and now this point onwards we will be drilling down into overloading, and specifically, as I have told you in the initial with the help of initial figure, I have explained that there are two types of overloading. One is function overloading, another one is operator overloading. So presently we are focusing on the function overloading only. So now what is function overloading? Function overloading is actually, we can say, is something through which we can achieve compile time polymorphism. This is what we have kind of as an established fact. Now what actually happened in function overloading, that we will see. Here two functions can have the same name. What is different between these two functions? The number and the type of argument, or we can say number of the argument or type of argument is different, but the name is same. So basically functions are having same name but different arguments are known as overloaded functions. Now there can be, it's not necessary that there can be only two functions with the same name, or you can have two versions of the same function with different parameters. No, there can be multiple functions with the same name but different parameters, and then these functions are said to be overloaded. So with let's say for example I am taking sum. So sum is kind of a function which I am making in it's a user defined function in my program, and I am having one version of function which is taking 2 parameters, another version of function which is taking 3 parameters, third version of function which is taking 4 parameters. So multiple functions can be there with the same name and different parameters. Now in order to overload these functions, what we need to be kind of very specific about is we need to have change in number of arguments or and change in types of arguments. So either one of them or both, that is number of arguments and the type of arguments must be different and the name is same, then these functions are known as overloaded functions. So let's kind of have an example to see it more clearly. So in this function, what is being done? This is a program to compute absolute value, and it is working for integer as well as it is working for float parameter also. So basically we are going to calculate the absolute value of integer as well as absolute value of float, and the name of the function is absolute only. We will be having two versions of this function, one is for float value, another one for your integer value. So in this, if you can see, what I have written is float absolute, and in the parameter list there is only one variable which is of type float. The return type here is float. So absolute is the name, return type is float, and only one variable which is float. Now if that variable value is less than 0.0, as we are talking about float, we have taken here 0.0, then we will say variable is equals to minus variable and we need to return. So that means we are kind of, if the variable is less than 0.0, we are assigning it to be a negative, we are assigning it a negative sign, and we are kind of returning that variable. This is the version of absolute function for a float variable which is receiving a float variable. Now coming to the version of absolute function with integer type parameter. So here if you can see, so what is the change between the previous one and this one? So here the return type is integer, name of the function is same, that is absolute, but the type of parameter is different, and we have seen if variable is less than 0, variable is equals to minus variable, and then we are returning the variable. So if you can compare, or if you can see the two versions of this absolute, name is same, what is different? Type, number of parameters is also same, both functions are having only one parameter, but the type of parameter is different, and of course yes, return type is also different. I will be coming to the issues of return type in a while. If we can see, the number of parameters I was talking about is same, but yes, the type of parameter is different. Here one parameter of type float is being passed, and here one parameter of type integer is being passed. So now how are we going to use this overloaded function into our main program? So let's see. So it actually depends on the call. Let's see how it goes on. So I can say, if you can see in the first statement what is being returned, it is being returned as C out absolute value of minus 5 is equals to, that's in double inverted commas, will be printed as it is, and the first call to absolute goes with minus 5, and here minus 5 is nothing but an integer value, right? So this particular call is going to, or this particular statement is going to call the version of absolute which is returned for integer variable. Now if you can see the second one, the second call is absolute 5.5f. That means this statement is going to call the function absolute which is having the parameter of as the float value. So how it is actually being achieved, let us try to understand. So working of polymorphism, if you can see in the main function, when I have called absolute minus 5, if you can see the figure here, it is going to call the version of absolute which is for integer, and on writing absolute 5.5f, it is going to call the version of absolute which is written for the float variable. That's what we can say, kind of a matching is happening there, and how this matching is happening, or what is the sequence of having this matching, that also we will be taking up in a short while. So we can say these functions are not same, absolute for integer and absolute for variable were different. So overloaded functions may or may not have different return types. So I have told you I will be coming to the return types. Now see, if there is only the difference of return type, else everything is same name we are looking for, same number of arguments, same type of argument. Only if it is the return type which is differing, compiler will not be able to kind of differentiate between the two, I can say, and then it is going to throw an error. For example, let us see here what is being returned. There is a function test which is taking one integer parameter and returning an integer. Similarly, there is a function test which is taking an integer parameter but returning a double. So now if we compare these two, what is the difference? The name is same, number of parameters same, type of parameter same. The difference here in between two tests is just the type of return type, I can say. So one test is going to give you integer and another test is going to give you double. So both the functions are having same name, same type, same number of arguments, only return type is different. Hence the compiler is going to throw an error because compiler is not going to differentiate between these two just on the basis of return types. That's not the criteria. That is one thing. Now after having a kind of a good platform build in function overloading, let us try to explore some more kind of theoretical aspects of this concept of function overloading. Let's try to see what are the advantages. So if you can see, the program has become kind of simple and readability, kind of usage of the program increases. So program becomes simple and easier to understand with the help of function overloading. And this function overloading, it also saves the memory space, maintains consistency, it makes a clear interface for the methods regardless of the parameter type and readability of the program. So if you are building an interface, that's also kind of that is more concise and clear. Now using the function overloading concept, we can develop more than one function with the same name, but the argument part should be different. This is what kind of we have established. And when I was telling you about the differences of compile time polymorphism and runtime polymorphism, that time I have also mentioned this point, that function overloading executes the program faster as compared to function overriding, which is nothing but runtime polymorphism, because all the bindings takes place at the compile time itself. Now these were the advantages. One is kind of readability of the program increases, and it comes as a natural way of writing the functions which are having the same name, and also the faster execution. These are kind of advantages of function overloading. Seeing to the disadvantages of function overloading, we can say the function declarations that differed by return type cannot be overloading with the function with the process of function overloading. That was very clear. We have seen in the previous we can say previous example that there was a test function which is having everything same except the different return type. So that is not acceptable. That we need to be very cautious about while coding the programs. And if any static member function is declared, then the same parameters or the same name cannot be overloaded. So static kind of parameters or static member functions, again we have to be very careful with if we are kind of going with the function overloading. So two disadvantages: static member functions cannot, we can say static member functions cannot be overloaded, and next thing is only the return type difference is not going to give the essence of or flavor of function overloading, we can say. So now if kind of we can try to recapitulate this whole, try to summarize this lecture. So initially we have started with what actually polymorphism is and how it is kind of useful in object oriented programming paradigm. Then we have seen types of polymorphism, which is compile time and return time, and in a to a greater depth we have seen the difference between the two, what is actually compile time polymorphism and what is actually runtime polymorphism. And within the compile time polymorphism there are two things available, one is function overloading, another one is operator overloading, and we have seen some exactly I can say some part of function overloading. So we have seen one example of function overloading, that how it happens, how it is actually implemented inside, that we have also seen. And the then towards the end of the lecture we have seen what are the disadvantages and as well as what are the advantages of function overloading, specifically with relation to C++. So hope you had a good learning in this lecture. Thank you for a patient hearing.